Hi folks, welcome back to 8.8. And in this video, we're going to talk about addition, subtraction, and scalar multiplication of vectors. All right, we're going to take a look at 4 examples, and then we'll write out some formal notation for ourselves. All right, so the directions here say examples 1 through 4, perform the desired operation. Then graph the original and resulting vectors. Okay. All right, so let's start with number 1. We have some standard form vectors here, right? With the brackets, the pointy brackets. And we have 3 comma -4 plus -5 comma 1. And as it turns out, vector addition works exactly how we would want it to work. In fact, we're going to take our 3 and our -5, and we're going to add them. So 3 plus -5 is -2. And that comes from the first component. And then we take our b's, oops, our -4 and 1, and we add them. Okay, so that's sort of the process, but what are we really doing? Okay, let's go ahead. We're going to graph this first vector using pink. Okay, so 3 -4 means that I'm going to start from the origin. I'm going to go over 3 and up 4. Just kidding. We're not going up 4, right? I see the numbers 3 and -4. So I am going to start here and I'm going to go +3, but I have to go -4. Okay. And the way I'm going to notate this, I'm going to have my initial point and my terminal point, terminal meaning where it ends. And I'm going to go ahead and connect them. And I'm going to put an arrowhead in the direction of that vector. Okay, remember, the vector has not just a length, but it also has a direction. Now, we're going to go ahead and take this second vector, -5 comma 1, and we're also going to draw it from the origin. Okay, so -5, I'm going to go -5, and it's +1, so I'm going to go up 1. Okay, and I'm going to connect that. So I have, oops, here's my terminal point and my initial point, and I can go ahead and connect them. Okay, so what I've done here is I've actually gone ahead and drawn 2 vectors in their form where they have a starting point, a terminal point, or sorry, an initial point at the origin. Okay. However, when we add vectors, we're actually lining them up head to tail. So instead of drawing this green vector starting here, I'm actually going to move the initial point to where the end of the first vector is. Okay. And so what I mean by that is from here, I'm going to count 5 to the left and 1 up. So 1, 2, 3, 4, 5, 1. And now I'm going to connect those with a nice straight line. There's the magnitude of my vector. And here, that arrowhead shows me the direction. Okay. Now, why is it important to line them up head to tail? All right. So we might start to see that we have almost a triangle. If I could just connect that side, I would actually have the triangle. Okay. So check this out. What happens if I connect the head of this vector to the tail of that vector? So All right. I went from the origin 2 to the left and 3 down. 2 to the left and 3 down. Okay. So when we're adding the vectors, sure, we can take the A's and add them together, and we can take the B's and add them together. But what we're actually doing is saying if we lined up the two vectors head to tail, what is the resulting vector? Okay, so this one in the blue right here, we can label this with our resulting vector. Okay. And the pink one and the green one are our original vectors. All right, so we've done the operation, but we've also drawn the picture so we sort of know what it is that we're doing. Okay. All right, let's try the same thing with example 2. So let's add them first. My 3 and 2, and then my -4 and 1. And by add, I mean we're really taking these and subtracting them or adding by a -1, right? So 3 minus 2 is 1, and -4 minus 1 is -5. And this is our B, and this is our A, okay? And I'm going to go ahead and draw the original vector and the original vector, and then I'm going to draw the resulting vector, okay? So let's get that original vector here. We're going 3 to the right and 4 down. So 3 to the right and 4 down from the origin. And there we have our first vector. And now from here, from the arrowhead, we're going to draw one that's 2, 1. Okay. So from here, we're going to go over 2 and up 1. All right. Now, if I were to draw this in, okay, I might say, well, then the resulting vector would be something like this, and that's 5, -3. But that's not what I have here, right? So what's wrong with what I just did there? I did it just like example 1, right? I drew the vectors, the head of one vector to the tail of the other vector. So how come it didn't work? Well, turns out this negative actually means that we have to go ahead and change some things about our drawing, okay? So this negative means we don't draw it in this direction, but we actually draw it in that direction, okay? Kind of like the unit circle. We've got the negative, so we just count in the other direction, okay? So I'm going to go ahead and erase this. And instead, I'm going to go over 2 and down 1. And now I draw my arrowhead. Okay, so these are now my original vectors. Now, if I draw my resulting vector, let's see what we get. Over 1 and down 5. Perfect, okay? So, key point here, plus means you line them up head to tail, but the minus means we go in the other direction, okay? We go in the other direction. All right, so let's just write in for ourselves that we have a resulting vector over here, okay? So adding them, you line them up, you draw them the way that they're meant to be drawn, but the minus actually means that we go in the other direction, okay? All right, let's take a look at example 3 here. So I see this 2 in the front, and I see a 1 comma -2 inside the brackets. Now this works exactly how you would hope it to work. We take the 2 and we distribute it inside the brackets. So we end up with 2 comma -4. Okay. Now, what does this original vector look like? Okay. So what is it that we're really doing here? 1 -2 means I'm going to go 1 and I'm going to go down 2. I'm going to connect these and draw that. Okay. So this is the original vector. The new vector, 2 -4, is going to start here, and I'm going to go over 2, down 4, like this. Okay. And so even though I covered up the pink vector, we see that the pink vector, if I double it, I actually get the blue vector. Okay. So really, I have 1 minus 2, but I'm doing 2 copies of that. So once and then again. And that's how I get this scalar multiplication. No change in the direction, same direction, just changing the magnitude, making it longer. Okay. All right, let's take a look at example 4 here. This time I see a -2 on the outside. We're going to follow the same idea. I've got a scalar on the outside, the -2. I'm going to multiply it on the inside, so we get -2 comma +4. And if I draw my original vector, 1 -2, okay, and I draw my resulting vector, -2 comma 4, okay, I see that the blue one is twice the length of the pink one, and the negative means I go in the opposite direction, just like I did with the subtraction example above, okay? So addition works the way you want it to. Subtraction, you go in the opposite direction. Scalar multiplication works the way you want it to. And if you have a negative, it means it goes in the other direction, okay? Now, before we finish this video, let's take a look at how we might see these as rules written, okay? And these rules, if I have 2 vectors, let's call them v1 and v2, okay? And a scalar quantity m, meaning it's just a number, it's not in any brackets. If I wanted to add these two, okay, so if we wanted to add these, a1, a2, I add the a's together. And if I wanted to add the whole vector, I'm going to take my b's and add them together as well. Okay, so it works exactly the way we want it to. And if we have a scalar and we want to multiply it, we just distribute it in like we would if it was parentheses, okay? All right, so my friends, that's it for this video. In the next one, we're actually going to start to talk about magnitude and direction. All right, see you back here.